Very good morning all. Good morning. Very good morning all. Good morning. So, chaliye let us start. Great. Chaliye let us start. Shall we start, dear students? Wonderful. Wonderful, wonderful. Chalo. One second, please. Straight away, let us go. Okay, what I do is, first I'll take up some very good numericals. I have selected these numericals in such a way that they are not like very tough or so, like it's not that research level, because you know what is quality, fitness of purpose. I had selected questions in such a way that they have fair chances of appearing in examination. So I took some very good questions where there is a chance. So moderate level, high level, all mixed together. Okay. So let us start, my dear students. Are you ready? Chalo, chalo, chalo. Are you ready, all of you? Tofu, Abhishek, tofu. Yeah. Okay, first, and it's a request to all of you. Please keep your calculators ready. All of you, please keep your calculators ready, because think that we are in examination hall, and let us do it very seriously. Let us do it very seriously, and think that you are in examination hall. Okay, na? Chalo. Let me take up. So first, I am taking up some questions. So I selected questions in such a way that it covers almost all areas. Entropy, first law, second law, then availability, all these are touched. Okay, na? Chalo. Let's take the first question. Please read the question. There is a chance. So I'm not saying these questions will appear in examination, but I'm trying to cover in such a way that in and around some concepts will be cleared nearby. So I'm not taking all, because in this class it is not possible for me to cover all the things. So whatever is possible I am doing. Chalo. Okay, please read the question first. All of you read the question first. I request you to read the question first. Okay, read the question first. Let me read. 5 kg of ice at minus 10 degrees centigrade is mixed with 20 kg of water at 8 degrees centigrade in an insulated vessel. What is the temperature of the mixture when equilibrium is established between ice and water? Then find the change in entropy. Look at carefully why I have selected this question. So it is a combination of first law, that is conservation of energy, and entropy. That's why I had selected this question. And moreover, it also includes pure substances, that is phase change, entropy change. That is the reason for selecting this question. So let me do this question. So if you see ice, there is ice whose mass is 5 kilogram and its temperature is, initial temperature of ice is minus 10 degrees centigrade. And I had told you in class very clearly when I was discussing your regular classes, when you calculate entropies, we take temperatures in Kelvin. I told you very clearly, so don't worry about that. Let me explain again. And what he says is, this ice is mixed with water, and the temperature of water is given as 80 degrees centigrade. So this question covers like 3 chapters. One is entropy, one is pure substances, and the other is conservation of energy, that is first law of thermodynamics. That is the reason for selecting this question. Chalo. And what is the mass of water? The mass of water is 80 kilogram. So let me explain what the question is. we have 20 kg of water. I'm sorry, this is not 80 kg, 20 kg. 20 kg water at 80 degrees centigrade is mixed with 5 kg ice at minus 10 degrees centigrade. So if you observe this clearly, my sense says water is at very high temperature, 80 degrees centigrade. Okay, good. Now you know 100 degrees, if you want to convert ice to water, and if nothing is given, I treat the pressure to be atmospheric pressure, and if you see mass of ice is 5 kg and mass of water is 80 kg, तो मेरा sense बोल रहा है कि the thermal energy of this water is higher than the thermal energy of ice, because water has a temperature of 80 degrees centigrade and water has a temperature of 80 and ice has minus 10, and the mass of ice is low and the mass of water is 20 kilogram. Wonderful. So what we do is, first let us try to calculate the equilibrium temperature. So what is the equilibrium temperature? Heat lost by water, which is at high temperature, should be equal to heat gained by ice. Now understand carefully, if you understand very clearly, ice is at minus 10 degrees centigrade. First, this ice gets converted from minus 10 degrees centigrade to 0 degrees centigrade. If nothing is given, I assume everything to be at atmospheric pressure. So 0 degrees centigrade is the phase change for ice. So pehle ice from minus 10 to ice at 0. Then ice at 0 to water at 0, that is latent heat. Again water at 0 to water at some equilibrium temperature T. Let us assume that the equilibrium temperature of this mixture, finally, let it be T. Let me take that T in degrees centigrade, because all these temperatures are in degrees centigrade. There is no problem at all, because whenever we have difference of temperature, it doesn't matter whether it is in Kelvin or degrees Celsius. All of you, can you hear me? All of you, can you hear me? Bolo ek baar. Bolo re. Wonderful, wonderful, wonderful. Blur दिख रहा है. Is it blur? Is everything fine? Yes, thank you, thank you, thank you. Chalo, let's proceed, dear students. Let's proceed. Now let us calculate the equilibrium temperature. So please note down that ice mass is 5 kilogram and ice is at minus 10 degrees centigrade. I repeat, mass of ice is 5 and the temperature of ice is minus 10, and water is at 80 degrees centigrade, and mass of water is 20 degrees, mass of water is 20 kg. So let me write heat gained by ice. Look at carefully. Mass of ice into specific heat of ice and delta T. देखो एक बार, first it is at minus T. So it should be converted from minus 10 to 0 degrees centigrade. So what is the difference? 0 minus of minus 10, it is 10. So directly I am writing this as 10. Wonderful. How did you get this 10? 0 minus of minus 10, that is, it is gaining. So therefore there is an increase in temperature from minus 10 to 0 degrees centigrade. So the difference is finally 0 and initially is minus 10. 0 minus of minus 10 is this, plus. Once the ice reaches 0 degrees centigrade, now there will be phase change. What is that phase change? Mass of ice into latent heat, and the latent heat is already given to us as 330 kilojoule per kg. Wonderful. Now you know, my dear students, this ice now got converted into water by absorbing latent heat, and then that water is now converted into what? The same mass, because whatever ice mass conservation is always valid. So whatever ice mass is there, that is converted into water. Now I write the same ice mass, and don't think that it is ice. In fact, it is water. That ice which got converted to water. Now please note then that it is the specific heat of water. Now ice got converted into water into delta T. I don't know what is the final temperature. Let the equilibrium temperature of these two be, let it be T, and it is converted from which temperature? देखो एक बार. Ice at minus 10 to ice at 0. Ice at 0 to water at 0. Now water is at 0 degrees centigrade. So T minus 0. And please note down that as 0 is in degrees centigrade, this is also in degrees centigrade. So please note down that let the equilibrium temperature be this. So can I say this is the heat gained by ice? That should be equal to heat lost. It is losing from where? It is losing from, who is losing? 20 kg water is losing from where 80 degrees centigrade to some T degree centigrade. Again, 80 is in degree centigrade, T is in degree centigrade. Whenever it is difference in temperature, it doesn't matter whether it is in Kelvin or degree centigrade. So now I write mass of water, specific heat of water into 80 minus T. Why are you writing 80 minus T? Because it is losing. Loss is for initial minus final. Gain is final minus initial. So now let us substitute values. The mass of ice is 5 and look at specific heat of ice into 10 plus 330 plus specific heat of water into T minus 0, and that should be equal to mass of water into specific heat of water into 80 minus T. Please note down that these temperatures are in degree centigrade. Wonderful. So dekho 5, the specific heat of ice is given as 2.1 into 10 plus 330 plus, you know, the specific heat of water is not given, but I'll take it as 4.2, and T minus 0 is T. What is the mass of water? Please note down that this is whole bracket because same ice is converted into water, and this is a separate water, that is whose mass is 20 and the specific heat is 4.2, and it is 80 minus T, where T is equilibrium temperature. So everything is known except the value of temperature. So this is 2.1 into 10 is 21 plus 330 plus 4.2 into T is equal to 4.2 into 4 into 80 minus T, and if you calculate, you will get the temperature which is in degree centigrade. I'm waiting for your answers. Anyone? What is the temperature? What is the temperature? 47.23 is the right answer. 47.2 I got when I calculated. I got 47.28. Please bataiye, are we clear? Is the temperature clear? Anyone? Please give correct values. Dear students, please give correct values. Calculate karo. Yes, 47. Now, can we write this in Kelvin? Shubhra, Aditi Gupta, Priyansh, wonderful. Venkat Ramana, Sarthak, very good. And if you want in Kelvin, add 273. That is, if you add 273, it will be 270. What is the value in Kelvin, dear students? You add 273, तो ये आ रहा है आपका 320.8. Wonderful, 320.8 Kelvin. Now, if you see the question, dear students, if you see the question, what is the final temperature of the mixture under equilibrium? We have calculated, no problem at all. And you should be very careful. If it is a fill in the blank question, if it is a fill in the blank question, dear students, अगर ये fill in the blank question है, तो if it is asked in degree centigrade, put it in degree centigrade. If it is asked in Kelvin, put it in Kelvin, and you should be very, very careful. No problem at all. Now let us proceed. Now अब क्या चाहिए? Now what do you want? Entropy change of ice, entropy change of water, and entropy change of universe. Wonderful question. Let's do this. एक second रुको. What is the initial temperature of ice? Minus 10 degrees centigrade. I told you very clearly, when you are calculating the entropy changes, temperature should be in Kelvin. I had told you very clearly. So therefore, this should be equal to 263 Kelvin. Wonderful. Now, what is the final temperature of ice? Just now you calculated. It is 320.8. Final equilibrium temperature 320.8. So, अब देखना, how do I calculate the entropy change of ice? Look at carefully. You know, for solids and liquids, the entropy change is given by MC ln T final by T initial, where T is in Kelvin. Let me repeat. For solids and liquids, the entropy change is given by, because they are incompressible generally, so therefore I have derived in my regular classes that TDS is equal to DH minus VDP, or TDS is equal to DU plus PdV. From there you can easily derive. So therefore, let me calculate. First, IC is converted from minus 10, that is 263, to 0 degrees centigrade. Let me write 263 Kelvin to, that is minus 10 degrees centigrade to 0 degrees centigrade. So here it will be, what is this, 273 Kelvin. So पहले ये calculate करना. First this entropy change, then latent heat. What is latent heat? 330. Then from 0 degrees centigrade to already we got 47.28. Matlab ye 273 Kelvin and the final temperature is 320.8 Kelvin. Let me repeat, sirs. Minus 10 degrees centigrade to 0. Then 0 to 0 phase change. Then 0 to 47 and keep temperatures in Kelvin. Ab dekh raha. So first I'll write mass of ice, specific heat of ice, ln. T final by T initial. Ice ka final temperature kya hai? So it is converted from 263 to 273. That is 273 by 263 plus. This is the entropy change when ice is changing its temperature from minus 10 to 0 degrees centigrade. Now, what is the entropy change during phase change? Latent heat by temperature, Q by T. The heat transfer during phase change is latent heat. So therefore, mass of ice, latent heat by temperature, and this saturation temperature at which the phase change is taking is 0 degrees centigrade plus. Now water, this ice is converted into water. So therefore, the same actually it should be water, but I'll write this as ice because the mass is same, and specific heat of water and ln. What is the final temperature of water? That is 320.8 by initial temperature is 273 because it is converted from 0 degrees centigrade. Water is now converted from 0 degrees to 47. 0 degree is 273, 47 is 270.8. So ab dekhna, mass of ice is 5 and the specific heat of ice is 2.5 into ln. 273 by 263, absolutely fine. Mass of ice is 5 and the latent heat is 330. The phase change temperature is 0 degree. Don't put 0, it should be in Kelvin. That is 273 Kelvin plus mass of ice is 5 and the specific heat of water is 2.1 and sorry, specific heat of water is 4.2. I am sorry. So isko thoda change karo. This one, wonderful, wonderful. Sorry, no problem. Now, this is 4.2. 4.2 ln 320.8 by 273. Wow. Right. So 320 point this by 273. Can anyone tell the value? The entropy change of ice. Can anyone tell the value? 9 point. Wonderful, sirs. Entropy change of ice is 9.82. But I want the unit. Some of you have given just value. I want the unit. Idhar dekhna. Mass of ice is kg. And the specific heat is kilojoule per kg Kelvin. Wonderful. And this has no unit. It is a pure number. So therefore, it will be kilojoule per Kelvin. Some of you have not given the unit. Please give me the unit. Wonderful, sirs. Wonderful. 9.8 is correct. Wonderful, sirs. Now, let us calculate the entropy change of. Let's try to calculate the entropy change of water. How do I calculate? Dear students, how do I calculate? Dekho. Entropy change of water. You know, water is changing its temperature. 20 kg water is changing its temperature from what? From 80 degrees centigrade to 47.28. So first convert in Kelvin. So therefore it will be mass of water, specific heat of water, ln final temperature of water by initial temperature of water. So if you want the entropy change of water, so mass of water is 20 kilogram and the specific heat of water is 4.2 ln. The final temperature is 320.8. I think it is correct na? Ek baar check karna. 320.8 is correct. Divided by the initial temperature of water is 80 degree. What does 80 mean? 273. So kitna aega? This is 353. Am I right? So therefore, again it will be in kilojoule per Kelvin. Anyone? Minus 8.03. Wonderful, sir. Minus 8.03 kilojoule per Kelvin. Absolutely fine. Now, you know, if you take ice as system, water as surroundings, or the total entropy, because if you consider the heat transfer is taking place between only ice and water, so now what will be the entropy change of universe? The entropy change of universe, which is also entropy generation, is entropy change of water plus entropy change of ice. So ice ka kitna tha? 9 point, we calculated na, 9.82, and water is minus 8.03. What is the entropy change of universe? 1.78. Is it correct? No one is giving answers. Entropy change of universe, Sijo Cyrus, 1.78. What does it mean? What does it mean? Whenever the universe entropy change is positive, that means the process is, comment, process is, अरे यार क्या हो रहा है sir? 1.78 is correct. What is happening? Irreversible. Shubhra Saxena has given the answer. So whenever it is positive, indicating that the process is irreversible. Is it okay? Exactly. Wonderful. Now I'll go to the next question. Please read the next question. So all of you, is the first question clear, dear students? So I am trying to cover questions in such a way that it includes different areas. That is the only aim. Okay, I'm not saying these questions will come. Is the question clear? First wala, up go to the second one. Read the second one. Please, all of you, read the second one. Ek baar, read the second one. Come on. Venkatramana. Wonderful Venkatramana. Dr. Venkatramana. Chalo, go to the second question. Please read. Read the second question. एक बार पढ़ो. Now let me read. Two air streams, whenever it is given as air, don't ask me, you can treat it as an ideal gas. Whenever it is an ideal gas, you know that PV is equal to MRT, and please note down that in ideal gas equation, P should be absolute pressure and T should be in Kelvin, that is absolute temperature. So देखो, two air streams A, okay, एक बार लिखेंगे, there is air stream A and there is air stream B. These are air streams. Okay, mass of air is 0.8, the pressure of air is 15 and the temperature is 250. एक बार देख लेना, the mass of A is 0.8 unit kilogram per second, and what is the pressure of A and what is the temperature of A? एक बार check करेंगे. Pressure of A is 15, temperature is 250. Temperature is 250 degrees centigrade and pressure is 15 bar. Let me check once so that and MB is 0.5, 15, 200. 0.5, 15, 200. Mass of B is 0.5 kg per second and the pressure of B is 15 bar and the temperature of B is 200 degrees centigrade. Wonderful, sirs. और क्या बोला है? And mixed in a large chamber, supplied, and the chamber is supplied. Are mixed in a large chamber, and the mixed air is supplied at 10 bar to a turbine. Language में थोड़ा दिक्कत है. देखो, these two are mixed. When nothing is given, actually we take it as adiabatic mixing, because had it been non-adiabatic, he would have given heat transfer. So therefore, this is mixing. So after mixing, it is entering a turbine. This is the turbine. At what temperature it is entering the turbine? Let me check. So he has given something. It is entering the mixed air at 10 bar to the turbine. Okay, it is supplied and the pressure here is given as 10 bar. Wonderful, sirs. और क्या दिया है? 10 bar to the turbine. The turbine exhausts the air at 30 degrees centigrade. Means from the turbine it is exhausted. At what temperature it is leaving? 30 degrees centigrade. Let me explain the question. 30 degrees centigrade. Assume steady adiabatic. Oh, दिया है. Why do you worry? Assume steady adiabatic throughout, and neglecting kinetic potential energy changes. Okay, and the enthalpy and internal energy are functions of temperature alone. Cp is given as 1 and Cv as 0.78. Determine the temperature at the inlet to the turbine and power developed by the turbine. Let me explain the question, sirs. Let me explain the question. Air is entering at some condition, air is entering at other condition, and these two are mixed in a mixing chamber. यहाँ पे एक mixing chamber है. So this is adiabatic mixing chamber. After mixing, that mixed air, that mixture is entering the turbine and the entry pressure is given as 10 bar. And after developing power, This air is leaving at 30 degrees centigrade. So what is he asking in the problem, sirs? He is asking us to calculate what is, एक सेकंड देखो, बोला क्या बोला है टर्बाइन, क्या बोला है, what is the temperature at the inlet to the turbine, मतलब यहां का temperature is asked, what is the temperature at the inlet to the turbine, and finally the second question that is asked is what is the power developed by the turbine. That's all. This is an application of, again, what? Steady flow energy equation. So let us calculate the temperature. Don't worry, sir. एक बार I request everyone to read the question once so that I'll move directly. एक बार go through the question. See, why are you asking 5 to 6 hours hoga? See, whatever we are discussing, let us discuss, let us learn and go. How does this time matter? So, अगर आपको कोई time constraint है, तो don't attend. So, let us gain and go. Now, shall we proceed? सब ठीक है, sirs? Is everything fine? Is everything fine? Now, एक सेकंड सुनो. How do I do that? Wonderful, sirs. For the time being, एक काम करते हैं. For the time being, what I do is, I will remove this. For the time being, I will remove this. एक second, please. For the time being, let me remove this. It's there. I know that. Now, wonderful, sirs. Let this be A, let this be B, and look at carefully. Let this be C. At C, it is entering the turbine. So look at carefully. If you observe steady flow energy equation, what is that? H1 plus C1 square by 2 plus Z1G plus Q is the entering energy जो भी है. It is adiabatic. And you know, in mixing, will you get any work? No, it is just mixing. So already kinetic potential भी हट गए. So only what is left? Enthalpy. That's it. So can I write, my dear students, यहाँ पे सिर्फ enthalpy बचा है. MAHA entering, MBHB entering, total entering. If you apply the conservation of energy at this junction, total entering MAHA plus MBHB is equal to MCHC. Yes. So I will apply MAHA plus MBHB is equal to MCHC. Wonderful. Can you give me mass at the exit? Absolutely, I can. Every time there has to be mass conservation and energy conservation. So look at here. 0.8 is entering, 0.5 is entering. 0.8 plus 0.5 is mass at C. So what is mass at C? 0.8 plus 0.5, which is nothing but 1.3. One more thing. He only said that the enthalpy is a function of temperature. So air can be treated as an ideal gas. For an ideal gas, enthalpy can be written as CPT, and note down that temperature, whenever I use ideal gas equation, my temperature should be in Kelvin. So therefore, now I write here MA, what is HA? CPTA. I am not writing CPA, CPB, CPC because air. So when air is entering, I am assuming that if nothing is mentioned, I assume that specific heats are not functions, not varying with temperature. It is a function of temperature, but not varying with temperature. So therefore, look at carefully. CPTA plus MB. What is HB? CPTB, and that should be equal to MC. What is HC? CPTC. Enthalpy can be written as CPT. So CP is assumed to be same. It's not varying with temperature. So I get MA, and please note down that whenever I use ideal gas equation, temperatures are strictly in Kelvin. So therefore, MAHA plus MBT gaya, so sorry, CP gaya is MCTC. Absolutely fine. Now temperature should be in Kelvin. Add 273. So ये कितना होगा TA? Anyone? 32523 Kelvin. And here add TB. So what is TB? Add 273. So 473. So therefore, MATA plus MBTB is equal to MCTC. Absolutely fine. No problem at all. Absolutely fine. So therefore, MA is 0.8. करेक्ट ना? एक बार चेक करता हूं, MA is 0.8 and TA, what is TA? What is TA? TA कितना है रे? TA 523, it should be in Kelvin. 523 plus MB is 0.5, एक बार मैं चेक करता हूं, yes 0.5 and it is 473 and it is 473 and this is the total mass 0.8 plus 0.5, it is 1.3 into TC and that TC will be strictly in Kelvin. Please note down that. What is the temperature at the exit in Kelvin? Anyone? कोई भी आंसर नहीं दे रहे सर, बुरा लगता है रे। T3 503.7, wonderful, बहुत लोग दे रहे हैं 503.7 Kelvin and if you want in degree centigrade पूछ सकता है, there is a possibility, कोई प्रॉब्लम नहीं यार, 230.77 करेक्ट ना, और 230.7 डिग्री सेंटीग्रेड। होप यू गॉट दिस आंसर। सबको आया ये आंसर? बोलो रे, सबको आया? वंडरफुल। तो फर्स्ट पार्ट इज ओवर। एक सेकंड, व्हाट इज द, कहां है रे? डिटरमाइन द टेम्परेचर एट द एग्जिट ऑफ द टर्बाइन, ये आ गया। Now he is asking power developed by the turbine. कैसे करेंगे सर? Look at dear students. This is the turbine and it is entering. Already you have calculated the ये mix हो रहा है, देखो. This is A, this is B and this is leaving and the leaving temperature is given as 30 degrees centigrade. Absolutely fine. And it is entering. At what temperature it is entering? Just now you calculated. It is 503.7 Kelvin or 230.7. So it is 230.7 degrees centigrade, or if you write in Kelvin, it is 503.7. 503.7 Kelvin. Absolutely wonderful. So how do I calculate the power developed by the turbine? Absolutely. Kinetic potential energy changes are neglected. देखो एक बार. So if you write, so let us assume this to be D. D is the exit. D is the exit. So at C it is, or you can take this as 1 क्योंकि A B लिए. Let us take entry as 1, exit as 2. Don't worry. तो क्योंकि we have general convention of taking entry as 1, exit as 2. So how will be your equation? H1 plus C1 square by 2 plus Z1G plus Q is equal to H2 plus C2 square by 2 plus Z2G plus W. And you know very clearly वो क्या बोला है? What did he say? Dear students, right, I'm sorry, is everything fine? एक सेकंड प्लीज। हाँ, is everything fine? Now okay? Right, thank you. Okay, right. अब देखो, please look at, he said adiabatic throughout बोला है, ध्यान से सुनो, he said adiabatic throughout, so therefore Q is 0 and kinetic potential energy changes are neglected, ये भी गया. So we have H1 is equal to H2 plus W, and if you want W, it will be H1 minus H2. But this will give me, and one more thing. So the work developed by the turbine, it is an ideal gas, so H1 is CPT1, H2 is CPT2. One more thing. And whenever it is a difference in temperature, it doesn't matter whether it is in Kelvin or degree centigrade. If you keep T1 in Kelvin, keep T2 in Kelvin. If you keep T1 in centigrade, keep T2 in centigrade. It's not at all a problem. And one more thing. He is asking power. Power is equal to mass flow rate into work. Can you tell me how much mass is entering the turbine? 0.8 plus 0.5. After mixing, that mixture is entering the turbine. So 0.8 plus 0.5 is 1.3. So therefore, now I write power developed is m dot into work. What is that work? Cp into T1 minus T2. As it is a difference of temperature, I will take centigrade, centigrade, doesn't matter. No need to convert. How much mass is entering the turbine? 1.3. And Cp is given as 1. He has given it as 1. And T1 minus T2. And T1 is 230.7 and T2 is 30, and you will get the work in or the power in kilowatt. Anyone? What is the value of power? कितना आ रहा है सर? 200 yes, 261 kilowatt, correct. That is the power. That is the power. Okay ना? चलो. Let's take this question. Is the previous question clear, dear students? क्या previous question clear है सबको? Shall I move to the next question? If you permit me, shall I move to the next question? बोलो sirs. So what? See, turbine inlet pressure is 10 bar. See, look at, we are calculating, yes, during mixture there may be pressure losses. Right. Now next question. Read this question. Previous two questions, entropy, pure substances, conservation of energy. Now it is second law. Read the question. A heat engine, read the question carefully. सही दिख रहा है आपको? कोई प्रॉब्लम है? Let me check. थोड़ा ब्लर दिख रहा है क्या? पता नहीं यार. दिख रहा है आपको? Can you see? ब्लर आ रहा है. क्लियर ना? क्लियर? एक नंबर. थैंक यू. कोई प्रॉब्लम नहीं. लेट मी रीड द क्वेश्चन. अ हीट इंजन इज यूज्ड टू ड्राइव अ हीट पंप. ओके, देयर इज अ हीट इंजन. Let this be the higher temperature of heat engine. Let it take Q1. This is the heat engine. It is developing work W and it is rejecting, let us say, Q2, and this is the lower temperature. तो ऐसा करेंगे सर, एक सेकंड रुको. I'll do it like this. Okay, T1 and T2. Okay, no problem. T1 and T2. Now this heat engine is driving a heat pump. Means whatever the work is developed by the heat engine, that is consumed by heat pump. Let this be, listen carefully, the lower temperature of heat pump. तो क्या करेगा heat pump? It takes from lower temperature with some work input and then this is rejected at a higher temperature. Wonderful, sirs. ध्यान से सुनो. This heat engine is driving a heat pump and heat pump is absorbing from lower temperature with some work input and rejecting that heat to higher temperature. This is the situation. Read the question. A heat engine is used to drive heat pump. The heat transfers from the heat engine and heat pump are used to heat water circulating through the radiators of a building. बोल क्या रहा है देखो. Listen carefully. Whatever this heat is rejected, this heat and this heat put together, how much heat? ये वाला जो इंजन रिजेक्ट कर रहा है, whatever the heat pump is rejecting, these two are used for heating a building. So you tell me how much is the heat used for heating? That is, let me repeat, sirs. Let me repeat. तो clearly क्या बोल रहा है? देखो, the heat transfer from the engine, मतलब इंजन से जो ट्रांसफर हो रहा है एंड हीट पंप से जो ट्रांसफर हो रहा है, दिस हीट इज यूज्ड टू हीट अ बिल्डिंग. ओके, नाउ बिल्डिंग, इट इज गिवन दैट द एफिशिएंसी ऑफ द हीट इंजन इज 30% and the COP of heat pump is 4. Let me check. Efficiency of the heat engine is 30 and the COP of heat pump is 4. How much heat is transferred to the radiator water for every kilojoule of heat transferred to the engine? हम कितना हीट ट्रांसफर कर रहे हैं इंजन को? 1 किलोजूल. हर एक किलोजूल हीट ट्रांसफर के लिए बिल्डिंग को कितना ट्रांसफर कर रहा है? हाउ मच हीट इज ट्रांसफर्ड टू द बिल्डिंग? सो दैट इज Q2 plus Q4 is the total heat transferred, and he is asking for 1 kilojoule of heat supplied to the engine, how much heat total put together is supplied to the building? Is the question clear? Ajay, wonderful sirs. अब देखते हैं सर. वेरी सिंपल. नोवेयर टेम्परेचर्स आर गिवन. कहीं पे भी टेम्परेचर्स नहीं दिया. नोवेयर टेम्परेचर्स आर गिवन. इधर देखो. कैन वी राइट एफिशिएंसी इज इक्वल टू 1 minus heat rejection by heat supply? Absolutely. I'm talking about this engine. 1 minus, this is rejection, this is supply. So therefore, efficiency is given as 0.3 and that is 1 minus Q2 by Q1. So therefore, you will get Q2 by Q1. How much is Q2 by Q1? 1 minus 0.3, which is 0.7, and Q2 can be written as 0.7 Q1. No problem. Q2 can be written as 0.7 Q1. Absolutely. And Q1 is given as 1. We'll put it little later. So, मुझे Q2 आ गया. Now let us try to calculate Q4. And how do I calculate? COP of heat pump. Please note down that the purpose of heat pump is to maintain higher temperature. Correct. So higher temperature का heat क्या है? Q4. That if it is a heat pump, the desired effect is higher temperature. Don't see that it is at the lower, it is at the higher. ऐसा नहीं. यहाँ से लेके यहाँ दे रहा है. So this is the higher temperature. So what is the desired effect? Q4. And what is the energy input? W. So what is the COP of this heat pump? It is Q4 by W. Absolutely. How much is the heat pump COP given? 4 and Q4. And can you tell me what is W? Dekho, try to express everything in terms of Q1 because Q1 is given. Can we write efficiency as output by input? Yes. So W is equal to efficiency into Q1, or W is equal to efficiency is given as 0.3. I repeat, efficiency is given as 0.3. So W is 0.3 Q1. So W can be written as 0.3 Q1. So Q4 is equal to 4 into 0.3 Q1. So Q4 is equal to 4 into 0.3 is 1.2 Q1. So I want the total heat rejected to the building. From the engine, Q2 is going. From the heat pump, Q4 is going. Total is Q2 plus Q4. He asked that only. Q2 plus Q4 is asked. What is Q2? 0.7 Q1. And what is Q4? It is 1.2 Q1. If I put together, it will be 1.2 plus 0.7 is 1.9 Q1. But already Q1 is given as 1. So 1.9 into 1 is 1.9 is the answer. 1.9 kilojoule. Hope you got this answer. Hope you got this. Is it clear? The problem is not over, sirs. The problem is not over. Something more is given. What is that? There is second part. First part. Dekho, second part. Let's go to the second part. What is that second part? Let me check. Also find the heat transfer to the radiator water. मतलब radiator water का मतलब क्या है? वहां से building को जा रहा है. मतलब again he is asking same Q2 plus Q4. Same water circulating through the radiator of the building. That is that heat is going to the radiator water. That is Q2 plus Q4. अब बोल क्या रहा है देखो. Also find the heat transfer to the radiator water for each kilojoule of heat transfer to the engine. If the engine pump combination delivers a net output of 10% of heat transfer to the engine. Let me explain the question. Let me explain what this question is saying. Don't worry dear students. मैं explain करूंगा. अब ये second phase है देखो. इधर देखो. This is my T1. Can you see? दिख रहा है ये? दिख रहा है ना? ओके, दिख रहा है या फिर वाइट ले लो तो वाइट सही रहेगा. ओके, राइट. दिस इज माई Q1, दिस इज माई Q2 and let us say this is T2. Say it is developing work. Already the efficiency of the engine is given. How much is the efficiency of engine? 0.3. Can you tell me what is efficiency? Output by input. That is W by Q1. So what will be W dear students? It is 0.3 Q1. Now what he says is this engine heat pump, and heat pump is taking from lower temperature, say it is Q3, and rejecting it to higher temperature, that is T4. And again he is asking, this is going through to the building, that is Q2 plus Q4. He is asking Q2 plus Q4. लेकिन अब क्या है? The combination is delivering a net work output. Look at the question properly. Look at the question properly. If the engine pump combination delivers a net output of 10% of the heat transfer to the engine. In previous case, all the work which is developed by the engine is going to the heat pump. But in this case, I repeat dear students, in this case, some net work is obtained. How much that net work is obtained? He only said 10% of this Q1, 10%. So can I say this is 0.1 Q1? Absolutely. So how much work it is developing? The work developed by the engine is 0.3 Q1. Out of 0.3 Q1, a 0.3 Q1 is developed. Out of that, you are getting a net work output of 0.1. So how much is supplied to the pump? I repeat, ये हमारा इंजन is developing 0.3 Q1. Out of 0.3 Q1, 10% of this input, that is 0.1 Q1, is net output. So out of 0.3, 0.1 is net output. So how much are you supplying? So therefore, work input will be 0.2 Q1. अरे बाबा, are we clear? Wonderful, sirs. अच्छा लग रहा है. Very good. Most of you are giving answers. Absolutely wonderful. Wonderful, sirs. Wonderful. 0.2 Q1. Great. So now you tell me what is the COP. देखो एक बार. And one more thing. The efficiency of the engine is 0.7 and efficiency is 1 minus rejection by supply. I repeat, efficiency is 1 minus rejection by supply. So Q2 by Q1 is equal to, kitna aa raha hai? Efficiency is 0.3, I'm sorry. Efficiency is 0.3. So this is coming out to be 0.7. So can we write Q2 as 0.7 Q1? Absolutely. Ab dekho. COP of heat pump is equal to 4. And what is COP? Desired effect by input. Now the input is not W unlike previous case. In previous case, all the input was given to the heat pump. But in this case, second case, some of the work is obtained, some of the work is given as output and remaining is given as input. तो मुझे लग रहा है थोड़ा आप वर्क लिए तो प्रीवियस केस में आई गॉट Q2 प्लस Q4 एज 1.9. मुझे क्या सेंस हो रहा है? इन दिस केस आई एम गेटिंग समथिंग, तो डेफिनेटली इन सेकंड केस इट शुड बी लेस देन Q2 प्लस Q4 शुड बी लेस देन प्रीवियस केस. अगर आपका आंसर ज्यादा आ रहा है मतलब देयर इज अ वायलेशन ऑफ कंजर्वेशन ऑफ एनर्जी. समझ में आ रहा है सर? व्हाई? बिकॉज ऑलरेडी हैव एक्सट्रैक्टेड सम वर्क, सो देयरफॉर इट शुड बी लेस. अब देखो व्हाट इज दिस Q4 desired effect by work input. How much is the work input? Now it is not W, it is 0.2 Q1. So therefore Q4 is equal to W is 0.2 Q1. Q4 is equal to 4, इसको multiply करना, 4 into 0.2 is 0.8 Q1. Absolutely. Now I want Q2 plus Q4. Q2 plus Q4 will be equal to, what is Q2? 0.7 Q1. Q2 is 0.7 Q1 and Q4 is 0.8 Q1. So therefore it will be 1.5 Q1. Already Q1 is given as 1, so therefore it will be 1.5. Previous case it was 1.9, now it is 1.5. Please बताइए, is the question clear, sirs? अरे यार क्या हो रहा है sirs? Please comment. Wonderful, sirs. Now थोड़ा different level पे जाएंगे. We'll go to different level. Take this. Please read the next question. Please read the next question. Please read the next question. भयंकर clear. अच्छा. Let me read. Two tanks are connected by a valve. One tank contains 2 kg of carbon monoxide gas. And problem में ये भी दिया है, take CV is equal to 0.745 kilojoule per kg Kelvin. Read the question. This is also given. Come on. 2 tanks are connected by a valve. ठीक है, no problem. One tank contains 2 kg of carbon monoxide gas at 77 degrees centigrade and 0.7 bar. The other tank holds 8 kg of the same gas, that is carbon dioxide, at 27 degrees centigrade and 1.2 bar. मतलब there are two separate tanks, both contain carbon monoxide but at different conditions. I repeat, there are two different tanks and they are connected by a valve. Both contain same gas, that is carbon monoxide, but at different conditions. Now, the valve is opened and the gases are allowed to mix. Okay, the valve is opened and gases are allowed to mix. And gases are allowed to mix. while receiving energy by heat transfer from the surrounding. Oh my God! जब valve open किए तो surrounding से भी, from surroundings also there is a heat transfer. You should be very, very careful. The final equilibrium temperature is 42 degrees centigrade. One part of carbon monoxide was initially at 77. The other part of carbon monoxide was at 27 degrees centigrade. And these two constituents are mixed and the resultant final temperature, he said 42 degrees centigrade. Using ideal gas model, what is the final pressure in bar and how much is the heat transfer during the process? This is a good question, sirs. I request everyone to read the question once. I request everyone to read the question once. एक बार क्वेश्चन पढ़ो. Let us not waste time and proceed wonderfully. Yes, it's not adiabatic now. एक second. Let me explain. There is one container. This is the valve. And there is another container. Absolutely fine. Both contain carbon dioxide. Great. I don't know volumes, so randomly I took these dimensions. No problem. एक second रुको. हाँ. One tank contains 2 kg carbon dioxide at 77 and 0.7. एक second. 2 kg carbon dioxide, 2 kg. And 77 degree 0.7, 77 degrees centigrade and 0.7 bar. Absolutely fine. The other part is 8 kg 27 degrees centigrade 1.2, 8 kg 27 degree 1.2 bar और कुछ 1.2 bar. The valve is open and the final equilibrium temperature is 42. Finally, इधर देखा. अब ये वॉल्व को ओपन कर दिए, ये वॉल्व को ओपन कर दिए एंड फाइनली ये मिक्सचर का टेम्परेचर है 42 डिग्री सेंटीग्रेड. सो ही इज आस्किंग व्हाट इज द फाइनल प्रेशर. करेक्ट? शैल आई मूव अहेड? आप बोलो एक बार. इफ यू से यस देन आई विल मूव अहेड. अच्छा क्वेश्चन है सर, दिस इज अ गुड क्वेश्चन. लेट अस रेस्पेक्ट दिस क्वेश्चन. बाबुलू, नो कमेंट्स. अरे बाबुलू, यो या चलो आगे बढ़ते हैं. चलो लेट्स प्रोसीड. देखो एक बार, देखो. Can you tell me what the final mass is? There has to be conservation of energy and conservation of mass at any cost. दोनों भी कार्बन मोनोऑक्साइड है. This mass is 2, this mass is 8. So what will be the resultant mass, final mass? 2 plus 8. The final mass is, I will write it as, एक काम करते हैं सर, इसको 1 ले लेंगे, इसको 2 ले लेंगे and we'll take the final as 3. The final as 3. Finally, actually, when the valve is open, these two constituents, they mix with each other. You'll get a uniform temperature of 42 degrees centigrade. That is given. Great. So what is the final mass, dear students? This is, it has a 2 kg mass, it has 8 kg mass, and the total mass is 10 kilogram. Absolutely fine. अब बोलो, sir, already mass is given. अब क्या conservation करेंगे? Great. Everyone knows volume is an extensive property. If you want the total extensive property, it is the summation of individual extensive properties. Let the volume of this be V1, let the volume of this be V2, and these are rigid containers. So what will be the total volume of the mixture? V1, V2 finally mix हो गए, तो final volume will be equal to this volume plus this volume because they are rigid container, they are not elastic, so therefore V1 plus V2. तो आप देखना, he says ideal gas model, तो very simple. PV is equal to MRT. Already masses are given. So by taking conservation of mass, you are not going to get anything. Already दिया है वो, masses दिया है. So what will be the volume? Can we write it as MRT? And one more thing. Whenever it is an ideal gas, temperature should be strictly in Kelvin. फौरन आप Kelvin में convert करना. 77 degrees centigrade. Dear students, 77. Can I write this temperature as 350? Absolutely. Can I write this temperature as 300? Absolutely. Correct na? Correct na? Okay. Kelvin. And what about this temperature? T2, sorry, T3, final temperature 273 plus, मैं आप पे depend नहीं हूँ. It is 315. Absolutely fine. This is at 350. This is at 300 and the resultant mixture which is at 42 is 315 Kelvin. So can we write volume as MRT by P? Absolutely, why not? So V1 plus V2 is equal to this final volume. This volume plus this volume is this volume. अब देखना. V1, what is V1? M1. I am not writing R1, R2 because the gas is same. When the gas is same, whether it is R1 or R2 or R3, it is a characteristic gas constant which depends on the gas and molecular weight. So therefore, same gas hai to R same rahega. So I am not writing R1. M1 R1 T1 by P1 plus M2 R2 T2 by P2 V1 plus V2 is equal to V3. What is V3? M3 R T3 by P3. Absolutely fine because this volume plus this volume is this volume. So what is this volume? MRT by P. So M3 R T3 by P3. So R is gone. M1 T1 by P1. So therefore I write M1 T1 by P1 plus M2 T2 by P2 is equal to M3 So M1 T1 by P1 plus M2 T2 by P2 is equal to M3 T3 by P3. Absolutely fine. What is M1 given, dear students? M1 kitna diya? 2 kg. Temperatures should be in Kelvin. T1 is 350. And one more thing. Let us keep in consistent units. If this is in bar, this is in bar, this will be in bar. If this is in kilopascal, this is in kilopascal, it will be in kilopascal. No need to change. Already it is given in bar. So therefore, it is 0.7 plus M2. What is M2? Let me check. What is M2, dear students? M2 is 8 kilogram. So therefore 8. And what is the value of T2? Bolo re. What is the value of T2? Is 300. So therefore it is 300 by P2. What is P2? This pressure 1.2 bar. 1.2. And that should be equal to the final mass is how much? 1 second ruko. The final mass is this plus this. That is 8 plus 2 is 10. So therefore, now I will write this as 10 and the final temperature is 315 by P3. So this P3 will be in bar. So because these are in bar, can you give me the value of P3? 1.05 बोल रहे लोग. Wonderful sirs. अच्छा लग रहा है आपको पढ़ा के. Great students of India. This is the, and you know this question was asked in one of the BARC interviews to our students. कुछ नहीं है. How do you find the final temperature or final pressure? So this is simply a conservation of energy. Is it clear, dear students? Someone said 37.25. Wonderful. वाह, बहुत अच्छा लग रहा है यार. And you people are involving and you people are solving, and thank you all of you. God bless you and all the best. क्लास नहीं हुआ सर. ओके, खुशी से बता रहा हूं मैं. नेक्स्ट पार्ट अब ये कंप्लीट नहीं हुआ सर. Please read the next part. So final pressure. Please read the heat transfer for the process. Heat transfer for the process. कैसे करे सर? कैसे करे सर? एक सेकंड रुको. This is subsystem 1, subsystem 2 and my total system. There has to be conservation of energy, conservation of mass, and these two things you should always carry in your pocket. So what I do is, it is a closed system. So let me apply first law of thermodynamics, which is conservation of energy. So how do I get this? देखो, d dash q is equal to du plus d dash w. अरे यार, they are rigid containers. They are not elastic. When they are rigid containers, there is no work transfer. क्योंकि यहाँ पे कोई paddle wheel work या some other things are not occurring. Simply they are mixing with each other. You open the valve, they mix with each other, and there is no interaction of that system in the form of work transfer. Work transfer के लिए it should cross the boundary. तो सिर्फ only the energy that is crossing the boundary is heat. He only said it can interact with surroundings. So what is the work transfer? Simply ये container है, ये container है, and they are mixing with each other. You are not getting any work. So therefore this is equal to 0. And if you want the heat transfer, it is simply the change in internal energy. So what does it mean, dear students? So heat transfer is equal to change in internal energy. What is the change in internal energy? Final internal energy minus initial internal energy. Exactly. So can you tell me what is the final internal energy? You know clearly. फाइनली अगर आप देखेंगे, फाइनली ये पूरा सिस्टम एक ही कंडीशन पे है. सो बट इनिशियली दिस इज सब सिस्टम, दिस इज सब सिस्टम. लुक एट केयरफुली, दिस इज वेरी इंपॉर्टेंट. फाइनली ऑल माई फाइनल सिस्टम इज एट ए यूनिफॉर्म कंडीशन. माई कंप्लीट 8 plus 2 10 kg is at 315 Kelvin. So you know, dear students, for an ideal gas I can write internal energy as mCVT. If you want du, it will be mCVdt. If you want u, mCVT. So finally I will write the internal energy as m3cvT3. Don't write cv3. Cv, it depends on the gas, whether it is A or B or C, one or 2 or 3, it is the same gas, so Cv will remain same. Now what about initial internal energy? Look at carefully. What about initial internal energy? Internal energy or energy is an extensive property. If you want the total initial extensive property, it is subsystem 1 plus subsystem 2. This will give me the total initial internal energy, because internal energy is an extensive property. अगर आपको total extensive property चाहिए, if you want the total extensive property, this internal energy plus this internal energy will give me the total initial internal energy. So can I write the initial internal energy as U1 plus U2? Absolutely, everything is correct. So therefore the initial internal energy it is an extensive property, it will be U1 plus U2. What is U1? M1 CVT1. What is U2? M2 CVT2. Absolutely fine. Now all these temperatures, whenever I use ideal gas equation, temperatures must be strictly in Kelvin. चलो कोई बात नहीं. So if you want the heat transfer, my dear students, if you want the heat transfer, it will be change in internal energy. Final is 3 m3cvT3, and initially, final minus initial, initially it is m1cvT1 plus m2cvT2. Very good, great students. So अगर आपको heat transfer चाहिए, and m3 is let me check, m3 कितना है सर? m3 is 8 plus 2 10, correct ना? So it is 10. Cv is given as 0.745 and the final temperature is given, I think मुझे याद है कि 315 Kelvin है, सही है. So it is 315 minus m1. Let me check एक बार. m1 2 and the temperature of 1 is 350. 2 and Cv is 0.745 and the temperature is 350. Am I right? एक बार चेक करता हूँ. 350 है ना? 350, करेक्ट. इसका मास कितना? 8 and 300. So 8 and 300. This m2 is 8, Cv is 0.745 and this temperature is 300. Let me check the unit first. Mass is in kilogram, correct, and Cv is kilojoule per kg Kelvin, correct, and temperature is in Kelvin. So you will get the answer in this anyone. क्या? Kilojoule. What is the answer, sirs? वंडरफुल सर. क्या आंसर दे रहे रे बाबा, क्या आंसर दे रहे रे बाबा, वाह, वंडरफुल सर, बहुत अच्छा लग रहा है. 37.25 किलोजूल, राइट. व्हाट डज पॉजिटिव साइन ऑफ हीट ट्रांसफर इंडिकेट? ये पॉजिटिव हीट ट्रांसफर शो करा है. एक्चुअली ऑल दीज इक्वेशंस यू हैव अप्लाइड फॉर योर कार्बन मोनोऑक्साइड. So for carbon monoxide you are getting this heat as positive. What does it mean? What does it mean? आप ना कुछ comment नहीं कर रहे सर. Yes, it is gaining from surroundings. It is gaining from surroundings. Exactly. So therefore कहाँ गया वो? देखो, allowed to mix while receiving heat by heat transfer from the surroundings. Surroundings से my carbon dioxide is absorbing. That's why you are getting this as positive. A positive heat transfer indicate that my system, which is carbon monoxide, is absorbing 37.25 ना, if I am not wrong. Correct ना? बोलो सर जी. बड़े सर, सब बड़े बड़े लोग हैं यहाँ पे. अच्छा लगा? बोलो सर. अच्छा लगा रे? अरे यू पीपल आर नॉट गिविंग आंसर्स. अच्छा लगा? चलो, लेट्स टेक दिस क्वेश्चन. वंडरफुल सर. नेक्स्ट क्वेश्चन. वंडरफुल वंडरफुल वंडरफुल. सीजो साइरस. पृथ्वी. वाह अजय, वाह वाह वाह, वारे वाह. नेक्स्ट क्वेश्चन. Can't we use M1 U1 plus M2? अरे ललित माथुर, सुनो ललित माथुर हैज आस्क्ड वन क्वेश्चन. देखो एक बार, ही आस्क्ड वन क्वेश्चन. अच्छा लगा मुझे वो क्वेश्चन. ही आस्क्ड वन क्वेश्चन, सर can't I use M1 CV T1 plus M2 CV T2 is equal to M3 CV T3 in this problem? Can't I use this? वो क्या बोल रहा है? देखो इसका मतलब U1 plus U2 is equal to U3. He is conserving the internal energy. He said, can't I use this? Can anyone tell why? ये नहीं यूज करेंगे इस प्रॉब्लम में, पता है आपको? देखो एक बार, ये कहां से आए रे? डी डैश क्यू इज इक्वल टू डी यू प्लस डी डैश डब्ल्यू, वर्क इज जीरो. तो आपने क्या किया? इट इज फाइनल, इट इज इनिशियल. फाइनल माइनस इनिशियल इक्वल है, तो ये जीरो हो गया, मींस हीट ट्रांसफर जीरो. अगर ये एडियाबैटिक मिक्सिंग होता है, इफ देयर इज नो हीट इंटरेक्शन, अगर ये एडियाबैटिक मिक्सिंग होता है, देन आई वुड हैव यूज्ड दिस इक्वेशन. क्योंकि ये प्रॉब्लम में क्यों दिया पता है? आपने क्लास में एडियाबैटिक मिक्सिंग से ये इक्वेशन किए. जस्ट आई हैव चेंज्ड इट. नहीं आ रहा समझ में? Yes, it is not adiabatic. Had it been adiabatic, my heat transfer would have been zero. There is no work transfer. My internal energy will be conserved. When the internal energy is conserved, U3 will be equal to U final is U initial. Then in that case, U final, that is U3 is equal to U initial U1 plus U2. Then MVCVT1 वहां लिख सकते. लेकिन this is non-adiabatic. So therefore, be careful, dear students. Simple things are always complicated in life. अगर छोटे छोटे चीजों पे आप ध्यान नहीं देंगे तो मुश्किल होगा आपके लिए लाइफ. So that's why take care of even minute details. Okay, shall I proceed? क्या हो रहा है? हो का रहा है. चलो take this. अच्छा क्वेश्चन है सर. मैं थोड़ा I'll move aside so that you can see complete screen. Read the question. Please read the question. What's the date today? Right. Wonderful, dear students. So read the question. ये भी अच्छा क्वेश्चन है सर. Read the question. चलो, क्वेश्चन दिख रहा है सर आपको? मुझे थोड़ा ब्लर लग रहा है यार, पता नहीं क्यों. चलो ये क्वेश्चन कर लेंगे हम. दिस इज अ गुड क्वेश्चन सर. ये थोड़ा कॉन्सेप्चुअली बहुत सही क्वेश्चन है सर. ये थोड़ा लाइक पर्पसफुली आई हैव एडेड सो दैट योर कॉन्सेप्ट्स विल गेट ओपनड अप. ओके, लेट मी डू दिस क्वेश्चन. अच्छा क्वेश्चन है सर. लेट अस रेस्पेक्ट दिस क्वेश्चन. सो इज मतलब ब्लर दिख रहा है या सब सही दिख रहा है डियर स्टूडेंट्स? अच्छा, मतलब क्वालिटी क्या कहाँ पे आता है रही है? अच्छा, ये भी होता है क्या? कहाँ पे आता है ये बोलो एक बार. क्वालिटी इंक्रीज करना है बोले सम लोग. ये यू कहाँ पे आता है? ये सब गुड है ना? क्लियर है? सेटिंग्स कहाँ पे जाना है मुझे बताओ, बिकॉज आई एम नॉट यूज टू ऑल दिस थिंग्स. 3 डॉट्स. चलो कोई नहीं, आपको तो सही दिख रहा है ना? इज एवरीथिंग फाइन? या चलो, दिस इज अ वंडरफुल क्वेश्चन सर. थोड़ा कैलकुलेटर रख लो अपने पास. कीप कैलकुलेटर्स. लेट मी रीड द क्वेश्चन. व्हाट अ ब्यूटिफुल क्वेश्चन दिस इज. इट्स समथिंग लाइक दिस. Procedure may be a path function, but final answer is a point function. That's it. Your procedure may be a path function, but final answer is a point function. No matter what procedure you follow, I repeat, no matter what procedure you follow, my final answer should be same. Let me explain this question. क्या अच्छा क्वेश्चन है, देखो सर, थोड़ा प्लीज ध्यान दीजिए. इट्स अ वेरी गुड क्वेश्चन बिकॉज इट गिव्स यू अ बेटर अंडरस्टैंडिंग ऑफ हाउ वी सेलेक्ट अ सिस्टम. ओके. Air is contained in a vertical piston cylinder assembly fitted with an electrical resistor. Okay, let me draw that. Air is contained in a vertical piston cylinder assembly fitted with an electrical resistor. Absolutely fine. What do we have here? Air. Wonderful. The atmosphere exerts a pressure of 1 bar on the top of the piston. The atmospheric pressure is 1 bar. Wonderful, sirs. Which has a mass of 45 kg and the face area is 0.09. The mass of the piston is कितना है सर? 45 kilogram if I am not wrong, and the area of piston is 0.09 square meter. Let me check एक बार. 0.45, 0.09, correct ना? Right. Okay. Electric current passes through the resistor and the volume of air increases by 0.45. Understand words carefully. Increases to का मतलब फाइनल दिया होगा. Increases by मतलब difference. It is increased by 0.045 means the difference of volume is given. How much is that? 0.045. Very good. So the change in volume is given by, so I will write this as, because he said increases by bola hai, not increases to, 0.045 cubic meter. So this is nothing but the final volume minus, because he said increases by, not increases to. Absolutely fine. Chalo. While the pressure remains constant. Okay, no problem at all. The mass of air is 0.27 kilogram and the specific internal energy, specific bola hai per unit mass, by 42 kilojoule per kg. So कितना mass है रे? 0.27. एक second. So air mass is 0.27 kilogram, and do not get confused between piston mass and air mass. Piston mass is 45 kilogram and air mass is 0.27 kilogram, right? And he also said the internal energy increases, air का internal energy, and its ये air है, air means its air का internal energy increases by 42. Again increases to नहीं बोला, increases by मतलब change दिया है. How much is that? 42. So the internal energy change delta U, that is U2 minus U1 or U final, is given by 42 kilojoule. Specific दिया है, specific दिया है. एक second, is it 42? Yes. The air and piston are at rest initially and finally. Initially and finally मतलब हीट इलेक्ट्रिकल रेजिस्टर से एनर्जी ट्रांसफर हो रहा है. इनिशियली इट इज द पिस्टन इज समथिंग एट दिस पोजीशन, समवेयर एट दिस पोजीशन. नाउ करंट इज पास and slowly the gas is expanding due to the supply of energy, and finally the piston is here. So initially the piston is at this position, it is in equilibrium. Finally the piston is at this position, it is in equilibrium. So both equilibrium positions are given. And one more beautiful word is given. देखो, the piston cylinder material is ceramic composite and thus a good insulator. क्या मैं इसको adiabatic मान लूं? क्या मैं इसको adiabatic मान लूं? क्या मैं इसको adiabatic मान लूं सर? अजय you got 11.3, अजय 11.3, 16.06. ओके, देखो एक बार, इट इज अ गुड इंसुलेटर बोला है, मतलब कोई हीट ट्रांसफर नहीं हो रहा। पिस्टन और सिलेंडर वहां से इट्स नॉट, दे आर नॉट कंडक्टर्स, सो हीट ट्रांसफर नहीं हो रहा है। वंडरफुल सर्स। फ्रिक्शन बिटवीन पिस्टन एंड सिलेंडर वॉल्स आर इग्नोर्ड एंड द एक्सेलरेशन ड्यू टू ग्रेविटी इज 9.81। कैलकुलेट the heat transfer from the resistor to air in kilojoule for a system consisting of air alone and the system with air and piston। क्या क्वेश्चन है सर? मैं आपको बताऊंगा ये क्वेश्चन है क्या है। अब मैं बताता हूं, सुनो। लेट मी एक्सप्लेन द क्वेश्चन फर्स्ट बिफोर आई मेक एन अटेम्प्ट टू सॉल्व द क्वेश्चन। आर यू रेडी? क्या आप लोग तैयार है? ग्रेट स्टूडेंट्स, ग्रेट स्टूडेंट्स, लेट अस चेक, लेट अस चेक प्लीज। पहले क्या बोला वो? एक काम करते हैं सर, एक काम करते हैं, विल चेंज द कलर। ओके, आई विल यूज दिस कलर। ओके, अब मैं क्या कर रहा हूं, किसको वो सिस्टम मान रहा है? See the question, first part of the question. First part, determine the heat transfer from resistor to the air for a system consisting of air alone. क्या बोल रहा है? First, he is asking how much heat is definitely, ये इलेक्ट्रिकल रेजिस्टर कहां पे है सर? सिस्टम के बाहर है। When current is passed through this resistor, this coil get heated up. When this coil get heated up, ये गर्म है कॉइल और ये ठंडा है, so there will be heat transfer। मतलब because of the transfer of heat, the energy is transferred in the form of heat to this, because मैं रेजिस्टर कहां लिया? आउटसाइड द सिस्टम। ग्रेट। अगर रेजिस्टर को इंक्लूड करेंगे तो वो वर्क ट्रांसफर होगा, फिर भी वो एनर्जी ट्रांसफर होगा, नो प्रॉब्लम एट ऑल, कोई दिक्कत नहीं। अब बोल क्या रहा है? ओनली एयर एज सिस्टम, सिर्फ एयर एज अ सिस्टम बोल रहा है। तो व्हाट इज द हीट ट्रांसफर बोल रहा है, व्हाट इज द हीट ट्रांसफर पूछ रहा है। ग्रेट सर्स, ग्रेट सर्स। नाउ द क्वेश्चन इज, सी द क्वेश्चन, सी द ब्यूटी ऑफ दिस क्वेश्चन। ही इज टेकिंग ओनली एयर एज अ सिस्टम, कुछ नहीं बोल रहा, पहले बोल रहा है टेक ओनली एयर एज अ सिस्टम। आप बताइए सर्स। देयर इज एटमॉस्फेरिक प्रेशर, देयर इज वेट ऑफ द पिस्टन, देयर इज वेट ऑफ द पिस्टन। Look at weight of the piston. तो it is in equilibrium. So what does it mean, sir? अगर equilibrium में रहना है piston को, there is atmospheric pressure and there is weight of the piston. Correct na? And look at carefully. I want the force into area. So this atmospheric pressure into area of the piston, the total downward force, weight of the piston is downward, and this should be resisted by what? Air. Let the pressure of air be P air, but I want force into area. इसका मतलब क्या है? So I can easily calculate the pressure of air. I can easily calculate the pressure of air. Absolutely wonderful, no problem at all. So that pressure is, मतलब air pressure किससे balance हो रहा है? Piston weight and atmospheric pressure से। तो can I calculate the pressure of air, dear students? क्योंकि there is a piston weight, there is a piston weight, there is atmospheric, दोनों downward, और my air is exerting pressure in upward direction, so I can calculate the air pressure. Can I calculate? आप लोग कुछ नहीं बोल रहे सर, आप लोग कुछ नहीं बोल रहे। So balance करो, pressure of air into A total upward is equal to mg downward plus PATM into A. Absolutely fine. यहां पे मिस्टेक कर सकते हम। What is that mistake? The mistake is the atmospheric pressure is given in bar. तो can I write this as 100 kilopascal, 1 bar is 100। तो अगर ये kilopascal में रखेंगे, that is kilonewton per meter square kilopascal, area is in meter square, so this will be in kilonewton, लेकिन mg is in newton, तो किलो होने के लिए मैं इसको 1000 से डिवाइड करूंगा, so you will get this pressure in kilopascal. So let me do that. So therefore P air, I repeat dear students, unit का खेल है। What is that? If I keep this pressure in kilopascal, kilonewton per meter square into meter square, this will be in kilonewton. If this is in kilonewton, this should also be in kilonewton. But mg will be in newton. अगर किलो में कन्वर्ट करना है तो 1000 से डिवाइड करो. So if this is in kilonewton, This should also be in kilonewton. This will be in kilonewton only when P is in kilopascal. So what is the area of the piston? 0.09, and that should be equal to M. What is M? देखो piston mass, not this air. It is ये कौन सा mass है रे बाबा? Piston का mass. It is my gas is resisting this weight. So piston mass is 45 and G is 9.81 and correct na? Is it correct? And what is this? 1000. Absolutely fine. Plus atmospheric pressure. I am not rating 1 bar, 100 kilopascal, and the area of the piston is 0.09. So everything is known except air pressure. Air pressure. Can anyone give me the air pressure? 104.9. Let me check. आप लोगों को बिलीव करना सही है या गलत है? 104. Yes, great students. 104.9 kilopascal और 1.049 बार. Absolutely fine. एक बार चेक करूं मैं. 1.049. Correct. Absolutely wonderful. तो एयर का प्रेशर आ गया. अब देखो. Now let me write. It is a closed system. Let me write the equation. Look at carefully. My fundamental equation is d dash q is equal to dE plus d dash w. Some students may be wondering, sir, why are you not writing du plus dw? So, अरे my dear students, अगर हम dE लिख रहे हैं, मतलब वहां पे you will be taking kinetic potential energy into account. बट अगर हम काइनेटिक पोटेंशियल एनर्जीज को नेग्लेक्ट कर रहे हैं तो जनरली फॉर गैसेस एज द डेंसिटी ऑफ गैस इज लेस द पोटेंशियल, ये सिंपल लॉजिक है. मैं आपको एक सिंपल लॉजिक बताता हूं, सुनो. you are standing here, there is air column, air, and you are standing here and there is air column. The density of air is less, that's why the load that you are feeling here, definitely not, the difference is not that much. So height के साथ, so as gases have low densities, the potential energy changes are negligible. But वही अगर यहाँ पे पानी है और ये भी पानी है तो density is more, I cannot neglect. So generally for gases, potential energy changes are small. It can be neglected without introducing much error. So for gases, potential energy changes are very small and can be neglected. That's why अगर मैं potential energy, so now you tell me what is my system. अब आप बताइए मेरा system क्या है? मेरा system only air. Air means gas. For a gas, can I neglect potential? This is very, very important part, sir. What is my system? You tell me. My system is air, which is a gas. For gas, the potential energy changes are negligible. That's why I will write the equation as, so if I neglect potential energy changes, I will write d dash q is equal to du plus d dash w. क्योंकि यहाँ पे my system is only air. Wonderful. Now, air is my system. So I want heat transfer. Who is transferring that heat? From the electrical resistor. Look at the beauty here. From the electrical resistor, heat is transferred. Because of the transfer of heat, physically what is happening? Let us see. जब हम heat transfer कर रहे हैं, there is some internal energy change of this air, and some it is used in lifting the piston and displacing atmospheric air. तो यहाँ पे ध्यान से सुनो. When I take the pressure of air, it includes both. What is that? Piston weight is included already 1.049. 1.049 में दो components include है, एक atmospheric component, एक weight component. So if I calculate this piston is moved up, means don't think that only piston work, but there is atmospheric air also. If you want to move the piston, you have to displace this atmospheric air also. Means my air is doing work in raising the piston and displacing atmospheric air, but both are included in that pressure 1.049. फिर से बता रहा हूं, सुनो. तो 1 bar is, that is 100 kilopascal is for piston, and remaining this point कितना है रे? 4.9. क्या है 4 point? अरे 1 bar is 100 kilopascal. So 1.049. 1.049 means 1 is for atmospheric air, displacing atmospheric air, and remaining 0.04 is for this piston. मतलब जब हम calculate कर रहे हैं, when electrical heat, मतलब when resistor is supplying energy or heat to this air, its internal energy is changing, good, and then इट इज रेजिंग द पिस्टन एंड डिस्प्लेसिंग एटमॉस्फेरिक एयर। तो अगर हम एयर का प्रेशर लेते हैं उसमें दो भी आ गए, दो भी आ गए, मतलब आई विल बी कैलकुलेटिंग एटमॉस्फेरिक वर्क, आई विल बी कैलकुलेटिंग रेजिंग द पिस्टन वर्क। So therefore, whatever the heat is supplied, some is gone for changing the internal energy and some is for raising the piston and displacing atmospheric air. So दोनों एक ही साथ calculate कर रहा हूं. What is that? So when I include air pressure as 1.049, it has two components, मतलब displacing this and raising the piston भी आ जाएगा. Please tell me, is the concept clear? So now, एक second. How do I calculate work, sir? It is at constant pressure. It is at constant pressure. आप लोग कुछ नहीं बोल रहे हैं. Is it clear? Wonderful, sir. Wonderful. हाँ, अब देखो एक बार. Constant pressure का वर्क क्या होता है? At a constant pressure of gas, my air, it is lifting. At a now what is our system? आप बताइए सर, हमारा सिस्टम क्या है? Air. तो air का pressure is 1.049 and with that pressure it is lifting. So thereby, what is the work? What is the work? It is work is equal to pressure of air. Who is doing that work? Who is doing that work? My air. So air pressure and constant pressure work is pressure into change in volume. So work is given by this air pressure is 104 point, कुछ calculate किए थे आप. Air pressure is 104.9 ना? 104.9. And what is the change in volume? दिया है. The change in volume is 0.045. That is 0.045. Let us check the unit. This is in kilopascal, so kilonewton per meter square, and this is in meter cube. So therefore, kilonewton meter is kilojoule. So how much work is done? कितना आ रहा है सर वर्क का वैल्यू? कहाँ गया रे, कहाँ गया, कहाँ गया? 4.72. Work is given by 4.72 kilojoule. किलोवाट नहीं, किलोजूल. क्यों किलोवाट आ रहा है रे? Right. Now internal energy change. Can I calculate? Yes. किसका internal energy change हो रहा है? हमारे air का, हमारे air का. So therefore, the internal energy change is given by m into. अरे यार, he has given for 1 kg. I think he gave some value. देखो एक second. The internal change is 42 is this is the internal energy change of air. 1 kg के लिए 42 किलोजूल का increase हो रहा है. But how much mass of air is there? 0.27. 0.27. So therefore, it is 0.27 into 42. This is the total internal energy change of air. So therefore, 0.27 into 42, correct? Plus work. कितना work आ रहा है? 4.72. तो how much is the heat supply, dear students? कितना आ रहा है सर? कितना आ रहा है? 16.06 ना? Wonderful. 16.06 kilojoule is the right answer, but the problem is not over. But the problem is not over. But the problem is not over. Is it clear? Not over. Not over. Please, यहां तक सभी को समझ में आया? If you say yes, then I'll proceed, dear students. 11 point something DJ galat. DJ, how did you get 11.3? Nah. Next part. Next part is very interesting part. एक बार पढ़ो, एक बार पढ़ो. Next part is, initially you took only air as the system. Now he says, air and piston is the system. Oh, what changes qualitatively are we? Is it okay now? Is it okay? Is it okay now? All of you? Okay? पता नहीं क्या प्रॉब्लम है, ऑटोमेटिकली लैपटॉप गॉट शट ऑफ. पता नहीं यार. Is it okay? Is it okay? Okay, now let's do this question. ये अच्छा क्वेश्चन है सर. Okay now? Thankful to God. All of you? Yeah, thank you, thank you. Right. So please check करो एक बार. Now, the सवाल is, now the question is, चलो okay? Okay ना? Wonderful, 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 wonderful. Okay, okay. Let's not waste time. सब खैरियत? सब खैरियत. Okay, okay. चलो, after this, I'll give you some important tips so that you can follow in examination. इसके बाद, okay ना? चलो. Now the question is, अच्छा question है सर ये. एक second. Okay, good. Now, he says, इसको ले लेंगे. This is including piston, air and piston together is our system. अब ध्यान से सुनो. Air and piston is together our system. Qualitatively, what difference are you going to find? Let's see carefully. क्वालिटेटिवली क्या डिफरेंस हो सकता है एक बार देखेंगे. सो आई शुड गेट द सेम आंसर डियर स्टूडेंट्स. ओके ना? राइट. नाउ लुक एट केयरफुली. क्या फर्क है देखो. अगेन नाउ यू टेल मी, पिस्टन इज इंक्लूडेड इन द सिस्टम. Earlier piston was not part of system. Earlier piston was not part of the system. That's why we calculated work in raising the piston. A piston is also my system. Can anyone in the class tell now what is the work? क्या अगर आप ये बोलेंगे I'll be the happiest person. अगर piston is becoming part of the system, now what will be the external work? Anyone in the class? अगर आप बोलेंगे ना I'll be the happiest person. I will be the happiest person. I'm looking at your comments. Now work done on. Wonderful, Priyansh. Wah, wah. Friction will not come, re baba. Please, he clearly said friction is neglected. So why do you say friction is coming? Problem में clearly बोला है. Now, please note, someone said work is zero. गलत है वो भी. Previous case, we calculated what was the gas pressure 1.049, means that 1.049 included atmospheric and piston. That's why my air is raising the piston and displacing atmospheric air. But now piston is part of, piston तो मेरा system का part है. Now whatever the work is done, my complete system, देखो एक बार, my complete system is just displacing atmospheric air at a constant pressure. At a constant pressure, it is displacing atmospheric air. So what will be the work? So the work is nothing but displacing. My complete piston and air put together is removing this. My complete piston and air is removing air. So now the work done is just in displacing atmospheric air. At a constant atmospheric pressure, our air is displaced. So my piston and air put together is lifting or displacing air. So therefore at constant pressure it is lifting. So what will be the work, sir? Common sense देखो एक बार, मुझे पता नहीं ये कैसा करना चाहिए. Work is nothing but your force into distance in the same direction. तो क्या करेंगे सर? You know this distance. How much is the distance? Can I calculate this distance as change in volume by piston area? अरे यार, so this देखो ये जो डिस्प्लेसमेंट वॉल्यूम है, कैन आई कैलकुलेट दिस एज चेंज इन वॉल्यूम इज इक्वल टू एरिया इनटू लेंथ. सो एरिया इनटू लेंथ चेंज इन वॉल्यूम. ओके, अब देखो, नाउ दिस इज रेजिस्टिंग. सो व्हाट इज द वर्क? एटमॉस्फेरिक वर्क, ओनली एटमॉस्फेरिक वर्क, ओनली एटमॉस्फेरिक वर्क. क्या आप लोगों को समझ में आ रहा है सर? अरे यार, पूरा पिस्टन मेरे सिस्टम का पार्ट बन गया. सो व्हेन पिस्टन एंड एयर एक सिस्टम बन गया. अब वो क्या काम कर रहा है? दोनों मिला के क्या काम कर रहा है? जस्ट एयर को डिस्प्लेस कर रहा है. किस प्रेशर पे? कांस्टेंट प्रेशर पे एयर को डिस्प्लेस कर रहा है. तो व्हाट इज द वर्क नाउ? द वर्क इज नथिंग बट डिस्प्लेसिंग एटमॉस्फेरिक एयर. क्लियर? तो एक बार देखो, वर्क इज नथिंग बट रेजिस्टेंस. आप लोगों को समझ में नहीं आ रहा, मैं बताता हूं, सुनो. लेट मी एक्सप्लेन वेरी क्लियरली. वर्क इज नथिंग बट कितना रेजिस्टेंस ओवरकम कर रहा है. इधर देखो, मैं आपको बताता हूं. दिस इज माई सिस्टम. नाउ पिस्टन एंड एयर. अब ये क्या है? एटमॉस्फेरिक एयर. हाउ मच फोर्स इट इज एक्सर्टिंग इनटू एरिया? हाउ मच फोर्स इट इज एक्सर्टिंग इनटू एरिया? तो अब देखो व्हाट इज वर्क, इस रेजिस्टेंस को ओवरकम करने में, तो हाउ मच डिस्टेंस दिस सिस्टम हैज मूव्ड x. Can I write that x as change in volume by area of the piston? Yes. तो अब बताइए वर्क क्या होगा. वर्क इज इक्वल टू फोर्स दैट इज P एटमॉस्फेयर A, इतना फोर्स एक्सर्ट कर रहा है इनटू कितना डिस्प्लेसमेंट है, इतना रेजिस्टेंस को ओवरकम करेंगे x. एंड व्हाट इज A इंटू x, वर्क इज इक्वल टू PATM. What is A into x यहां से, what is A into x? It is delta V. So therefore work कितना होगा, atmospheric pressure is 1 bar. 1 bar means 100 kilopascal, 100 kilopascal into change in volume 0.045. तो कितना वर्क आएगा? So now it is 4.5 kilojoule. Is it correct? Is it correct? In previous case it was 4.72 if I am not wrong. Previous case it was 4.72. What is the reason for this difference? यहां पे प्रीवियस केस में सिर्फ एयर था मेरा सिस्टम, तो एयर को पिस्टन उठाने में काम हो रहा है और एटमॉस्फेयर को, यहां पे पिस्टन इज माय पार्ट, देयरफॉर ओनली एटमॉस्फेरिक एयर, दैट्स व्हाई यू आर गेटिंग लेस देन दिस 4.5. प्लीज बताइए, आर वी क्लियर? द प्रॉब्लम इज नॉट ओवर सर, प्रॉब्लम इज नॉट ओवर. अब ब्यूटी देखेंगे. Now we'll see the beauty. So actually we have calculated this work as कितना आया sir? How much is this work? 4.5. What is that work? That is the work done by piston and air put together in displacing atmospheric air. अब यहां पे बहुत इंपॉर्टेंट पॉइंट आ रहा है सर. Now let us see the most important part. What is that? D dash Q is equal to DE plus D dash W. Again students may be asking question, sir आप DU क्यों नहीं लिख रहे? मैं बताता हूं. Previous case air alone was my system. For air potential energy changes are negligible. But यहां पे look at carefully, my system is not only air but also piston. You may be neglecting the potential energy changes for air. What about piston? Piston is moving. So therefore यहां पे you should take, now I will write D dash Q is equal to, यहां पे सुनो carefully. So whatever the heat is supplied, some of the, देखो इसको 3 components में divide करेंगे. Whatever the heat is supplied by this electrical resistance, some of the heat is stored as internal energy, some is used for raising the potential energy of the piston, and some is used for displacing atmospheric air. All of you, have you followed? Please बताइए, जो हम heat supply कर रहे हैं, some is stored as internal energy. What is that internal energy? And you may be asking a question, sir my piston is also storing some internal energy. ना clearly वो बोला है it is ceramic, it is not absorbing any heat, so therefore only whatever heat is absorbed, मतलब store कर रहा है, only our air is storing. Piston is not storing. Piston का सिर्फ potential energy बढ़ रहा है. Let me explain very clearly. Now in second case हो क्या रहा है physically? When you are supplying heat, my air is absorbing, मतलब उसका internal energy बढ़ रहा है. When heat is supplied, the piston is raising, तो उसका potential energy बढ़ रहा है, and atmospheric air भी displace हो रहा है. तो जो भी conservation of energy है, whatever heat you are supplying, some is stored as internal energy, some is used in raising the potential energy of the piston. And you may be asking, sir, why are you not taking the potential energy changes for air? It is negligible. Please tell me, is the logic clear? Now let me calculate the internal energy change of air. तो कितना है? 0.27 into, already it is given, कितना इंक्रीज हो रहा है उसका? 42. So therefore into 42. ये कितना आ रहा है सर इंटरनल एनर्जी चेंज? एनीवन? इंटरनल एनर्जी चेंज कितना आ रहा है एयर का? 0.27. No one is commenting into 42. 11.34. Then what is the potential energy change of piston? MGH. Potential energy change of piston, MGH. Mass of the piston is 45, G is 9.81, and H. You tell me how much height it is rising. It is change in volume by area. समझ में आ रहा है? कितना वॉल्यूम चेंज हुआ? वॉल्यूम बाय एरिया इज हाइट. So volume change is, how much is the volume change? 0.045, and the volume of the piston is 0.0, and the area of the piston is 0.09. आप बताइए सर, is it clear? अरे यार, how much distance the piston is raising I am calculating. How do I calculate the height by which the piston is moving? देखो एक बार, piston originally यहां पे था, अब finally यहां पे है, तो क्या ना इसे इतना height raise हुआ? So can I calculate this volume? Yes. So can I say this is volume change? Volume change So how much will be this volume change? This will be area of the piston into x. अगर आपको x चाहिए, it will be delta v by area. The volume change is 0.045. Area of the piston is 0.09, and I think you are getting this as how much? कितना आ रहा है sir? 0.5. Wonderful sir. It is 0.5. It is absolutely 0.5. No problem at all. So therefore, what is the potential energy change of the piston? Piston, it is increasing. So why it is increasing? Because of the supply of heat. So G is 9.81 mgh. What is h? 0.5 meter. लेकिन ये किस में आएगा सर? M is in kg, G is meter per second square, and this is Newton, and this is meter. Newton meter is joule. लेकिन all are in kilojoule. So divide with 1000. So what is the potential energy of the piston? कितना आ रहा है सर? One is giving. क्या हो रहा है रे? क्या हो रहा है रे? 45 into 9.81 divided by 1000. I think you are getting 0.22 kilojoule. Yes, it is 0.22 kilojoule. Absolutely fine. Now can I write how much is the heat supplied? तो जो भी heat supply कर रहा है आप, some is stored in the as internal energy in air, that is 11 point. अभी हम कैलकुलेट किए, कितना था? 11 point. It was 11.34. Wonderful sir. So wonderful. It is 11.34. 11.34. एक second please. 11.34 is internal energy plus potential energy of the piston is 0.22, and the atmospheric work is 4.5. Atmospheric is 4.5. Total कितना आ रहा है सर? Total कितना आ रहा है सर? 11.34. No one is answering. Plus 0.22 plus 4.5. Again 16.06. See what is happening, sirs? What is happening? Same as previous. तो इससे मैं कुछ ब्यूटी बताऊंगा सर. आप लोग कंफ्यूज मत होना. इससे मैं ब्यूटी बताऊंगा. Please don't get confused. Please listen carefully. When I took this as the system, when I took only air as the system, what are the things? जो भी एनर्जी ट्रांसफर हो रहा है, that is stored and piston work. देखो एक बार, piston plus air को डिस्प्लेस करने में आ रहा है. Now when I took this as the system, only air work and potential energy changes and then stored in this system. Are you not getting the same answer? Are you not getting the same answer? आप लोग कुछ कमेंट करो रे. See the beauty of the question. See the beauty of the question. कुछ भी करो. Have you felt it? मतलब अच्छा लगा क्वेश्चन? अरे have you followed sirs? मस्त क्वेश्चन था सर, डेफिनेटली. लेट मी एक्सप्लेन क्लियरली. फर्क क्या आ रहा है देखो, इस आई विल टेल यू. दोनों में भी इंटरनल एनर्जी चेंज उतना ही आ रहा है. यहां पे यू टुक पोटेंशियल एनर्जी ऑफ पिस्टन 0.22 प्लस एटमॉस्फेरिक वर्क 4.5, एंड इन दिस केस दिस प्लस. अब देखो ये है तो रेजिंग पिस्टन किसमें लिए आप? वर्क में लिए. तो यहां पे यू गॉट 4.72. इफ यू एड दीज टू, आर दे नॉट सेम? इफ यू यहां पे कुछ कॉमन सेंस देखो, you are splitting this into two parts: potential energy, atmospheric work. But and internal energy तो सेम रहेगा बहुत दोनों में. But यहां पे क्या है? This potential energy is included, मतलब how much gas is doing the work, and this is included in both. Same आ गया देखो. So purposefully I have divided. Wonderful sir, अच्छा लगा. And please my dear students, I have tried my level best. I am not saying these questions will come in examination. I am not saying that questions will come from my notes. No. कभी भी खुद वर्क नहीं करेंगे तो कुछ नहीं होगा. Your teachers are only guides. They will guide you. But you people have to search for, hunt your own food. You have to search for new questions and you have to do of your own. until you do questions of your own, even if I do 1,000 questions, it's of no use, dear students. I never said that questions will come from my notes. Yes, they may be coming, concepts, but not all. So karo mehnat, and definitely we are working a lot, and abhi examination aane wala hai on 13th. So I got so many calls from students, sir, I'm losing confidence. Now only 10 days are left. What am I supposed to do? The problem with you people is you are thinking about the future. What if I don't succeed? What will happen? You are thinking on those lines. And if you think on those lines, definitely you are not going to succeed, I'm telling you. So you have to just work sincerely without thinking about the future and without thinking about the past. Stay in the present and just keep working, keep working. So when you enter the examination hall, don't enter the examination hall with some like intention कि I should crack the examination. So this is my life. ये सब गलत है. So beyond gate there is much life, and don't think that only gate is life. Now much is left. So whenever there is sincerity in your work, definitely God will give you much more. So apna kaam sincerely karna without any expectations, and there has to be dedication in your work, sincerity, and you work sincerely. If you work, definitely you will come out with flying colors. So, and please abhi now in these 10 to 12 days, don't do anything new. Whatever you have covered, I repeat, whatever you have covered, just revise those things. And health is very, very important. Stay home, don't roam here and there, just work hard. And you have to sleep for about 7 hours. That is required also for your best performance. And some people, they like work so hard, matlab they at the cost of health. So because in examination hall, so if your mental health is not correct, and you may not perform well, so sincerely apna kaam kar lena without any expectations. And if some of your friends say, this year this IIT is conducting examination, so I'm expecting so many questions from this area, X area, and say you have not covered that area, you get disappointed. So aisa kuch nahi rehta hai. There is no hard and fast rule that if this particular IIT is conducting examination, so questions will come from this area. No, it's absolutely wrong. So you have to cover all the areas, and equally sincerely you cover, and abhi no new areas to be covered. Just whatever you have covered, you just brush up, and don't involve in talking too much with your friends ki I have covered this, what areas can we expect. Ye sab chhod do. Do you have any queries, dear students? Sir, which subject you are going, which subject, sir, if possible, FM and HMT ka series? Yes, I am doing it on plus course. Regularly I am doing. Okay, और कुछ पूछना है आपको? So हम कोशिश करेंगे, we'll try our level best, happily we'll try our level best, and we'll enjoy our classes. And definitely, yes, I'm coming up with some new things. So definitely we'll try our level best. और कुछ पूछना है? नहीं? तो shall I end the class? So बताइए सर, अच्छे लगे questions? On convection, very good. आप टर्म कब से स्टार्ट शुरू कर रहे हैं? यस, डोंट वरी. यू हैव फेल्ड ऑन होम स्टडी. अब मेरी तरफ एक्चुअली इट वाज शेड्यूल्ड लॉन्ग बैक बिकॉज ऑफ सिवियर कफ एंड कोल्ड. आई वाज नॉट इन ए पोजिशन टू टेक क्लास, सो देयरफॉर आई पोस्टपोन्ड इट. प्लीज एक्सक्यूज मी फॉर दैट. न्यू बैच 16 फरवरी से स्टार्ट हो रहा है. और कुछ पूछ लेंगे? वीरेंद्र, होप आई हैव आंसर्ड. सॉल्व एंट्रोपी एंड अवेलेबिलिटी प्रॉब्लम्स. ठीक है विघ्नेश, ओके. और कुछ? या ये अवेलेबल रहेगा. चलो, या प्लस पर, या एग्जैक्टली. सो थैंक यू, गॉड ब्लेस यू, ऑल द बेस्ट, हैव फेथ इन यू. ओके, सो गुड लक, कीप वर्किंग. सो I'll try my level best. तो अपने मेरे से जो भी होगा I'll try my level best. So all the best. Thank you. I'm ending the session. God bless you.